Hi and welcome back to another LeetCode video. We're currently going through the bit manipulation problems on neetcode.io, which contains the neetcode 150, which is a curated list of 150 prototypical problems to practice common data structures and algorithms. And yeah, we want to complete this section today. So we're going to have a look at the medium problem, number 7, reverse integer. So we're given a signed 32-bit integer x, and we should return x with its digit reversed. If reversing x causes the value to go outside the assigned 32-bit integer range from 2, then return 0. Assume the environment does not allow you to store 64-bit integers, signed or unsigned. All right, and well, x can be any number within that 32-bit range. That's the only constraint. And how does a reverse number look like? Well, like this. Put in 123, you get back 321. Right, so I guess what we should probably do is we should think about how to handle the negative cases. Well, if we have a negative number, we might as well, we could just call our own function again by just passing it the positive number and then make the result negative, right? So if x is smaller than 0, all we do is we return minus self.result minus x, and we have successfully eliminated half of the number range and solved the problem for that. Now, what do we need to do next? Well, we need to compute the digits of those number. And well, how do we do that? Well, we already know, right? We have to have a result. This will be our inverted number, and then we just loop while our number has a value. We're going to pull out the last digit, x. And actually, I'm doing integer arithmetic here. I tried to solve this problem before with purely bit manipulation, and it was way too slow. So either I didn't get the right approach or I misunderstood the problem. But we're going to do it now with decimal arithmetic here, and maybe we have a look at the solutions later. But the way you would solve this, I guess, would be just like this. So we just do as our usual. We just pull out the last digits, and then we shift the number by dividing it by 10. And our result, well, we're going to multiply it by 10 to increase it, and then we're just going to add the digit that we pulled out. So this effectively reverses the number. I guess I'm kind of cheating because this isn't really using bit manipulation or bit operations. Now we just need to check whether, well, if result is smaller than int min, which is minus 2 to the power of 31, then we should just return 0, right? And if result is larger than, and what is larger? 2 to the 31st power minus 1, then we're outside of the positive range. Then we also return 1, otherwise we just return the result, right? So that's a quick way of how to solve this. Boom. And by the way, the runtime is log n, as is the space complex. So let's now look at some solutions. I'm kind of curious to see how they solve that. Python, clean, simple, beats, 100%, easy to understand. Okay, blah, 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 blah. All right, surprise. So that uses string manipulation. So that's kind of also cheating around. Now, the second approach here that looks like our approach, right? But it keeps a flag for the negative instead of calling itself. And then it does exactly the same thing. Then it checks, okay, it's exactly the same. I'm surprised. I thought somebody would have like a really nice solution that uses really only bit stuff. Reverse bits, Python, digit, push and pop. Interesting. But this also uses decimal arithmetic. Same. So is there anybody who can solve with only bit manipulations? Nobody the number flip nobody expected. All right, let's see. It's doing the same thing. So, well, I can show you what I tried. And no, I actually can't show you. I tried this solution before, but I did not submit the other one that only contained bit arithmetic, because that was a real pain in the butt to get that working. And it wouldn't even pass the test cases here, because it was just taking too much time to completely do this, right? So, yeah. So that's unfortunate. But yeah, I can actually show you that. Can I? No, I can't. Well, doesn't really matter. I guess we'll never know. Or if you know, please leave me a comment so that I can figure it out. That concludes this list here. And yeah, I think we have some more dynamic programming problems to tackle next.